Okay, then officially here now. Thanks everybody for joining. We have again more than 150 people in the room, and I think we have a packed program. And what I said, we have now international focus, people coming from all over the world. And the first pitch is about India. India is becoming very important. And here it's about the pitch is about how to become to India. But I think it's more important to know about the next event, battery innovation, and Max can say something about this.
Yes, thank you, Holger. Oh, you haven't given me the freedom of to be a presenter. Just to thank you very much. You already said that that India is a very important topic, and we as a network, the TraWeBa network, we are in contact with companies, and our goal is to help the German companies alongside the battery value chain. And that means not only to connect these companies within Germany, but to help them reach other companies in other countries in Europe, but also outside of Europe. And there we had been in really close cooperation with India and with Indian companies. And so based on this collaboration, we decided that next month there will be a special session of the battery innovation in the spotlights, featuring some Indian companies. And these companies are all declared interest in the German, in the European market. They are looking actively for collaborations. What is new? What stays the same? The date is the same as always, the second Thursday every month. So this time
it's a third Thursday next week, because the first is holiday.
Second Thursday. It will be the 8th of May. But okay. What is important to keep in mind is that we will have a new time. Due to the time difference, we will start at 11 o'clock, and we will then featuring these Indian companies. I think it will be very interesting. And so keep in mind, the time will change. The date is the same, 8th of May. And with this, I welcome the first speaker of today. It is Dr. Rainer Kern from the company 𝗕𝘁, and they have the goal to implementing the German technologies in India. And I don't want to say anything else about him. I think that sounds very interesting. And with this, I would say, Dr. Kern, the stage is yours, and you have 4 minutes.
Thank you so much for the introduction. I'm sharing my screen. I hope you can all see it. And I would like to talk now about building successful clean tech business in India. India is a large market for lithium batteries, actually for all energy storage systems, but here I would like to focus on lithium batteries. And we see a large market of more than 800 gigawatt-hour cumulative market size in India up to 2030. In India, the stationary energy storage sector is quite large. It's 45% of the overall market. And in the mobility sector, we have a large fraction of 2- and 3-wheelers. The Indian government strongly supports the building up of a local supply chain, a local value chain in India for the energy storage sector. And this is one production-linked incentive scheme to really support to build up gigafactories. On the other hand, also they're supporting projects. There's a viability gap funding scheme. So there's a large opportunity. The market really gains momentum at the moment, and India is really open to adapt also new technologies from Europe or from outside of India to really speed up the energy storage market in India. If you would like to go to India, there are several factors which are important. Sure, you need a stakeholder access. You need, on the one hand, access to the potential clients, but also maybe to potential partners for localization. You need a right go-to-market strategy. You need a team in India who has a technical experience, who understands your technology. You need somebody who has a culture experience, who understands the business culture and business models in India and the West, which are also different, also business models often. And you need in India a local team to implement your technology. I would like to share with you here the approach of 𝗕𝘁. We have a 4-step approach. The first 2 steps are the seed phase, where we do a market evaluation, and then the market presence with a lighthouse project. We want to do very fast a first commercial project to prove First of all, that the technology is accepted in India, also technology works. On the other hand, also that this product is commercial viable in India. And if these two things are proven, the technology and the commercial part, we go to the growth phase where we do then a local company, we localize it, and we scale the technology in India. I would like to present now 4 examples, what we did in the past on what we are doing at the moment. 𝗕𝘁 was one of the pioneers in India for the wind energy sector. We developed, built, and operated one of India's first utility-scale wind plants with German technology. We commissioned this in 2008. And at the moment, we are the bridge to India for SMEs, where we jointly do the way to India for clean tech businesses. We developed a go-to-market strategy for more than 10 innovative companies, where we also developed lighthouse projects with Indian partners. You see here examples of partners of us, and you see here 2 strong sectors. One is the energy storage sector, and the other is the smart grid sector. We also work with 𝗕𝗁𝘁𝗁𝗶𝗴𝗵𝘁, brought 𝗕𝗁𝘁𝗁𝘁 to India, Swiss lithium battery company, where we identified 𝗕𝘁 as potential joint venture partner, and we facilitated in the joint venture next charge between 𝗕𝗁𝘁𝗁𝘁 and 𝗕𝗁𝘁. At the moment, we also do the technology transfer and the localization for smart lighting technology. We work here on the one hand with our technology partner 𝗕𝘁 from Switzerland and 𝗕𝗁𝘁𝘁 from Austria, and we founded the 𝗕𝘁 Smart Energy for IoT-driven smart lighting solutions, where we also do the localization in India. Thank you very much, and I'm very much looking forward also to discuss with you.
Perfect. Thank you very much, and perfectly on time. And I think your presentation was the perfect teaser for next month to show what India can provide and how Europe and India can work together to help the battery ecosystem. But I guess there will be a lot of questions. Are there questions already from the audience? You can write them in the chat, but preferably just ask them. Otherwise, is there a question? Okay, I can't hear one. Then maybe let me start. What do you think is the biggest challenge India and and Europe can work together to solve that in the battery economy?
I think India is very strongly now building up a local value chain in the battery business, and I would like to start there. Before India also has the net zero target for 2070 and will be soon the largest market for renewable energy. And it's not only about renewable energy. The tenders are all that you have to provide round the clock energy. So it means you have to bring the right energy storage technology to India and build this up. And I think this is a great opportunity for both continents to do this.
Yeah, thank you very much. Are there other questions?
Is there somebody who wants to go to India? It's the opportunity, talking to an expert.
Yes, I would have a small question about India. So we fight for patent in India, and certainly we would be very interested to license our technology in India. Is that something that you also would potentially work with us?
Sure. As you saw, we have a business model sure that we localize technology, we bring technology to India, but we are quite open because you have to adapt it always to the technology partner, what you do. Definitely. I'm looking forward maybe afterwards that we can connect.
Thank you.
I will share just in the chat, I will share quickly the link of Rainer to LinkedIn. Just connect to Rainer directly. Just make a contact request. You can go into discussions. The big problem with email addresses is you can't simply copy them easily out of the chat. So that's the reason why the LinkedIn link is always better. And it's in the chat. And please use the chat if you want to introduce yourself to the audience. Please use the chat. If you use the chat, write only a little bit. Yeah, just write your LinkedIn link, maybe one sentence what you're doing. You don't want to do commercial in this writing. Okay, otherwise, please feel free using the chat for this one. Any other questions? If not, you can contact him directly. Yes, there's one question. Quick.
I have a question regarding integrators going to India for certain technologies. Like, I have seen that there are technologies which are available here in European countries, in America, in China, but in certain points, India need also integrators. So lots of integrators are also trying to establish their business in India. So just want to listen a quick perspective from you, how you see this strategy from such system integrators.
I think India already, you have in India also a lot of local companies which are integrators. And I think the companies in India who go into the battery field, also local Indian companies, are actually well capitalized and very good companies. So in a sense, if you as an integrator come to India, I think you have to have a clear business model, and I think you need also an USP in your technology.
Mhm. Thanks a lot.
I think India has a lot of
This just
already
because of
existing.
the timing, please go in the chat. You can have a
So-
let's have a chat on the chat, and then just
Sure,
connect.
Atul, we can
Sure.
connect later.
I have sent your request on. Thank you.
Perfect. So I close my thing. So we're coming to the second pitch. The second pitch is about virtual batteries. So what I understand from the recording, if you're looking at batteries, you have battery solutions for many applications. So many battery solutions for many applications. And you have a virtual battery. I understand now what a virtual battery is. You just have one system and you use a software to get all currents out there. So I think it's N level, and we have Gerald, but I can't see him currently.
I'm here.
Okay, floor is yours.
So hopefully the sharing is working.
Yes.
Yeah, thank you for the introduction of N-level. Today we will discover how we generate multiple currents from one battery pack using our virtual battery system. Yeah, the key problem is that various types of currents are needed for applications. Sometimes there are more than one application at the same time. From the chemical perspective, the current which is delivered from the battery, but it's only one. Today, each application needs its own solution to convert this current into the application current. For example, in cars, we have a 400 volt or 800 volt DC system, which is converted into a 12 volt DC system, or converted into an AC system for the powertrain. To get the right currents from batteries, usually a lot of electronics is used also in the private sector. So we are facing a bunch of different chargers for static applications, and all the companies are time intensive.
And all the companies.
The companies are time intensive in developing these devices. We use batteries for all things we do all day, like mobile phones, mobile transportations, even vacuum cleaner contain batteries now. Or you use a vacuum cleaner while you're charging your EV. What happens if we can use an app to get the right current from a battery pack anytime we want, only per app? So no power electronic is used, there's no conversion, and you can get any type of current you want, use any type of battery, and even you can repair and upgrade the system while you're in operation. Customers are using the N-level system, for example, for uninterruptible power supply. They reuse all their old batteries and scaling up the system, which is really easy scalable because you have a virtual layer in it. But how we do it? We have so many requests. and virtual battery is the general answer. So the virtual battery is the software layer on top of the batteries. So we adapt the chemical cells to your current. You do not need to care about the chemistry anymore. And how we are so fast in adapting, especially for multiple currents at the same time. So charging a mobile phone and driving a microwave, this is done by our patented and level algorithm. Today, we are looking for investors and development partners to apply and adapt our technology. And now I'm open for Q&A questions.
Thank you for your, as you're perfectly on time, so exactly 4 minutes 00. So any questions to end level? There you go.
Yeah, from me, Christian Hoffmann. I would like to know if you are considering battery cooling as well.
We do thermal management by switching and directing the loads into dedicated cells. So it's active power sharing.
Okay, thank you.
Okay, any other question? In the meantime, I will share the link to 𝗕hiểu so that you can contact him directly. Hold on. I shared him to the wrong person currently. Oops. Let's send it to everybody. Here we go. Here we go. There's a link. So that's the link to contact 𝗕hiểu. So how long have you developed? One question from my side. How many time you spent to develop this? What you have done?
It was doing 10 years of theory, doing also diploma thesis, and then doing 5 years hardware setups and writing the patents now.
Okay. Is there any other company doing things like that?
Some companies are doing comparable things, which they call multi-level technology.
Okay, is it used in automotive industry already? Something like that?
Porsche industry is going for multi-level now.
So it's an interesting technology then. Okay. Any other questions? If not, then we save some time. I have shared the link. Okay, Florian has also shared the link. So please connect to the people. Connect to the people to Rainer here, to Gerald here, and then get in contact with him directly if you want to become a development partner or an investor. That's the point. Okay, then handing over to Max for the next pitch.
Yeah, thank you very much. And I mean, we have more speakers than ever before, so it's good that we stay on time. And the next speaker I'm really looking forward to it, because sometimes things you don't think about are the most important. And Klaas Moser from the company 𝗕𝘁₀ will now tell us why insulations in batteries are important and why they need to be durable as well. Mr. Moser, the stage is yours.
I'm ready. I'm sharing. Let me see. Screen 2. Share. Here we go. So my name is Klaas Moser. I'm Business Development Director for e-mobility for 𝗕𝘁₀. And what we do in e-mobility is insulation coatings. And we have done this for roughly about 12, 13 years. Started in Germany. 𝗕𝘁₀ is a German company. And expanding in the world for, let's say, about 4 or 5 years now. Very active in India. So I like what you mentioned before about India. And I totally agree to the statements which have been made about India. Very active region. Let's see, why can't I change here? What we're going to look at today is basically the difference of durability between PET film, which is used very commonly on battery cells, if they're now cylindrical or they are prismatic cells. If we look at the throughput of PET film for the application is 6 parts per minute. Insulation coating, 60 parts per minute, so quite fast. If we look at the issues we hear from the market and see in the market as well about the adhering process, there is 99.5% production rate, so no failure with insulation coatings. Bubbles during application of PET film, of course, on coating not existing. Change of equipment for different cell size, not necessary for coating. You can use different cells, different type cells, different size cells through the same application equipment. Wrapping process is not easy to handle all the time, and the coating process is fully automated. The adhesion of the film against the can surface is normally very low on PET film. It's very high on UV insulation coating. We're going to look at this in the next slide. Poor vibration and friction performance, that's super important for cars. It's important for trucks on challenging roads in various parts of the world. Long-lasting protection. So the target for us now is up to 25 years. And significantly better thermal conductivity. So that's a rough overview. PET film to the left, UV insulation coatings to the right. And this is the main topic and the major advantage of the coating, the insulation coating. If you do a test, it's called lap shear test. So you coat 2 cells together or 2 panels together and you rip them apart. And it's always the glue failing. There is never any bare aluminium underneath, which comes up. If you look at the PET film, the PET film is always ripping off the battery cell and leaves bare exposed aluminium on the outside, which of course is very tricky if you have coolant, if you generate corrosion. So this battery cell will not last very long anymore. The reason for this, and now we're getting very technical, that we have on the coating only one glue film. It's the glue film in between the 2 coatings. You glue the battery packs together, or the cells together in the battery packs. I'm sorry, you glue the cells together. You have one glue, and you got another coating film, and you got another cell. If you look at the PET foil as an example, you have normally three glue points. You got between the battery cell, you got the foil, then you got the glue, and then you got foil again, and then you got a glue film again. And it's this glue film here, which is normally damaged due to vibration, due to movement, slight movements in your pack. It's always damaged in this area between and leaves bare aluminium open.
Sorry, just a reminder of the time. Please come to an end. Otherwise, we run into problems.
To an end. To the left, we see the UV coatings in terms of mechanical lap shear strength, and to the right, the adhesive films. So up to about 17 on the left on the coatings and barely nothing on the adhesive films. Last one. Similar is with the electrical climate after climate chamber. to the left, you see the UV coating. To the right, you see the adhesive films. So massive different beginning of life, end of life, beginning of life, end of life. And I believe this is it. This is where we are: Germany, China, Mexico, and India. This is it. Thank you very much. Oh, that was quick.
Yeah, 4 minutes run by fast. That is true. But thank you very much for the interesting overview. Maybe first question, it sounds like the coating is so much better than the PT isolation or insulation. Do you have some numbers, like how many batteries are actually produced by this coating technique compared to the PET films?
Up to now, we have produced about 800-900 million cells for one big car maker in Germany. We now starting for a big car maker in Sweden with similar quantities, and so on. Everybody which does this comparison between PET film and coating is moving towards coating. Lots of activities in India with variable companies, lots of activities in Europe with cell manufacturers, OEMs. So at the moment for us, it's full blast converting to insulation coating.
That sounds very promising and a growing market. And
massive.
Yeah, in batteries, there is so much innovation still to be implemented in the batteries produced right now. It's very inspiring to hear that. I think in the looking at the time, one short question is possible, and then we have to head over to the next speaker. I see Alex Chen, you have a question. You are still muted.
Please.
Alex, we can't hear you. You have to unmute yourself. Otherwise, write your question in the chat.
Hi. Hello. Yeah. Can you hear me? Thank you for your time. Yeah, Mr. Moser, could
Yes,
you?
we can hear you.
Yeah. Mr. Moser, could you tell us whether you use UV printing or UV spraying method for this technology?
It's UV technology.
UV printing, UV printing or UV spraying?
I don't follow the question. UV? Can you just write me the question and I will send it back to you?
Yeah. UV printing, printing.
Oh, not UV printing. We're looking at UV printing, but currently we use UV coating.
UV coating, spraying, like spraying, yeah.
Yes.
Like the car building line, yes.
Yes.
Okay, I see. Thank you.
Thank you.
Thank you very much. And we go to the next speaker.
Yeah, I've shared the link for class in the chat. So Alex, if you just I share it again, so you see it's the last one. Just click on and connect and then I will direct chat with them.
Thank you very much.
Okay, let me quickly. Let's go into the wrong room here. Okay, here's a link again. So connect directly to class, please. I don't know, is Carl there? I haven't seen Carl in the room, so we might have one pitch less. So therefore, if there's one more question, we can go for one more question, if you guys want to. If not, then we're going over to recycling, and recycling is Maximilian's topic again, because we have two very nice recycling topics.
Yes, important topics, and I'm really happy to have both speakers today on board, because the importance of recycling is big. We have the geopolitical importance. I think everybody's aware of this right now. And also by law, companies will be forced to use a certain amount of recycled material in their new products, in the new batteries. And there is also from our network an estimation of the Fraunhofer ISI, and that this recycling market, just the material recycled every year in Europe from 2030 ongoing, will be a multi-billion-dollar market. So these are just some cornerstones why recycling is important. And with this information, I would like to welcome 𝗕𝘁𝘁𝗲𝗿𝗵 from the Graduate School of Management in Leipzig. They have a Horizon project with a goal to establish such a recycling facility in Saxony, which is the part I'm living in Germany, so I'm really glad about that. And yeah, 𝗕𝘁𝘁, I hope you are here, and the next 4 minutes are yours.
Maximilian, thank you very much for introduction. Can you hear me well?
Yes, I can hear you very well.
Excellent.
Yes.
Thank you for giving a short introduction into the recycling topic. It's a big pleasure to be joined for the first time the TraWeBa network. Thank you very much for all the participants for their attention. Well, we are the new guys on the block. The project funded by European Union called SafeLoop, and HHL, Graduate School of Management, is one of the participants in this project. My role is helping SafeLoop succeed in terms of innovation management. So the project itself is R&D stage, gradually entering into the market implementation. Just briefly about the SafeLoop, the goal of this project is to develop a safe and sustainable high-performance lithium-ion battery for European electrical vehicle industry. We have 15 partners from 11 countries, and together these partners form the entire value chain for battery pack development. So from sourcing the material until the manufacturing the battery pack and integrating it into the electrical vehicle. So the situation at the moment is that within the next 5 years, the world should expect generating approximately 2 million tons a year of wasted lithium-ion batteries. The estimate varies depending on the source, but this is approximate scale of what will happen soon. And there is an opportunity. First, we could improve unit economics of lithium-ion batteries by recovering some of the rare active components that are expensive and reusing them inside of a recycled battery. And the second opportunity is more like the need to follow European Union regulations. So by 2030, 70% of lithium-ion battery should be recycled and 95% of cobalt. This is a very rare and politically sensitive material, and 80% of lithium, which is difficult to recover from the battery. They should be recovered by law. And so this offers a very interesting situation where companies should think how to reorient themselves and really utilize recycled batteries inside of their products. The problem, however, is not really only the recycling process. How do we extract these materials? The really difficult issue is how do we manufacture a recycled battery cell which has a competitive cost. It's not very expensive. It has a comparable performance to non-recycled battery cells, and it doesn't blow up when you turn it on, because after the recycling process, we never get ideal or perfect active materials. They damaged during the process to a different degree. And so designing a battery chemistry which actually takes into account all these issues is important. And this is what SafeLoop is, as a consortium, is trying to do. So on the cost-effective side, one of the project partners... could you please turn on the microphone? Thank you. So one of the partners develops novel direct recycling technology. This is a really safe and careful method of extracting active materials without creating any slur. On the performance side, to ensure that the chemical performance is enhanced, some of our project partners develop novel materials, add different additives and nanoparticles to really enhance the chemical performance. And on the safe side, We developed novel non-flammable electrolyte formulation. And so together this combination of solutions we hope would lead to a more stable, safe, recycled battery cell. So as soon as this element can be produced and project partners from the Safe Loop from different countries develop these technologies, the desire and the hope of HHL here in Leipzig and Saxony is to transfer these technologies into Germany and developing, let's say, a facility which uses these recycled battery cells in the battery pack, and really through the circular business model, maybe through leasing of the battery pack, or maybe through other ways of developing circular relationship with operators of battery packs, on a permanent basis, integrates the battery pack, removes it, then disassembles it, replaces the cells with the new recycled cells, and keeps the battery pack in operation. And so what we at HHO hope to achieve is to build this, in the long term, this organization, integrated recycling lithium-ion battery company. And for that, I would like to invite those who are interested in pilot studies with the recycled battery pack to contact me. This is a long-term strategic project, but we will be very interested to establish this relationship up front. And also, just a little comment, those of you who manufacture or is a supplier of EU-made cathode materials, please also reach out. Thank you very much for your attention.
Thank you very much. A little bit over time, you have to leave some time for the questions, but yes, I couldn't agree more. The recycle of batteries must start with the production. And I think we have already the first question, so please go ahead.
Just wanted to ask, I mean, whether there are any LCA studies being done around to really look at whether this is actually beneficial. I am just asking because I come from a plastic recycling side of things, and while people come up with new methods and so on and so forth, it's usually not beneficial for the environment to do some of these things. So I just want to know. I'm not from the battery field.
Yogo, thank you very much for this question. We have a partner from Imperial College who is working on life cycle analysis, and at this stage, we are analyzing whether it makes sense economically, environmentally. Our assumption from the literature, from limited cases in the world, that under certain conditions, recycling makes sense economically, so it's economic feasibility, and with a proper organization of the process of recycling. So, for example, using direct recycling methods, which is challenging, but still, we need some innovation in direct recycling. Yes, it's possible also to reduce the environmental influence.
Yeah.
Thanks.
Perfect. I'm afraid we already have to move to the next pitch. I've many more questions, and Dimitri, I think we will meet again anyway and discuss this in detail. And if more people have questions to Dimitri, I'm sharing his LinkedIn link right now in the chat. Please connect with him, ask him the questions. The recycling is a very important topic, and our next speaker is fitting into this topic really well as well, because recycling is actually only the last step if you look at the circularity of a battery. And so I'm welcome on stage David 𝗕𝘁𝘁𝗿𝘆. He's from the Research Institute Fraunhofer EVU here in Saxony, and he will talk about the innovative battery systems and circularity for a sustainable future. David, the next 4 minutes are yours.
Okay, share screen. Okay, so hello everyone. My name is David 𝗕𝘁𝘁𝘁𝘿, and I'm a research associate at the Fraunhofer EVU in the working group Battery Systems. And as part of the Fraunhofer Society, we are a non-profit research organization with the goal to boost the industrial base for the benefit of society. And we do that by transferring our cutting-edge technologies. IWU is short for Institute for Machine Tools and Forming Technology. And in German, it makes total sense. So if you look at our competences, you will find machine tools and forming technologies, but many, many more. So as you see that our different competences are far exceed what the institute's name may suggest. And this is also true when it comes to the applications. On the field of battery systems, we focus on module and system level, but there are also some activities on cell level, for example, forming processes for cell housings. The implementation and the end of life of battery systems is also a very important field of research. When building our battery systems, we already take end of life processes into account and design the systems accordingly. In our projects, we can start at different stages of the system development. For example, we can start at a white sheet of paper and create our concepts tailored to the requirements of the given application. Then we bring our concepts digitally to life and we optimize the thermal and mechanical properties simulation-based. And we also build physical demonstrators and prototypes. And to verify the simulation results, we have a large number of different test stations where we can perform tests on material, component, and system level. Especially for traction batteries, we have different bollard tests where we can adjust the geometry of the bollard as well as the impact energy by height and mass. As an example of a project, I brought you the 𝗕𝘁𝘁𝗵𝗵𝗵 project. There we rebuilt the EQS battery housing with many innovative components. One of the tasks was to improve the floor panels, and here we used aluminum foam sandwich structures that were infiltrated with phase change material for passive temperature control. And this will reduce the energy consumption of the temperature control unit. And most importantly, this project, it's an investment project in which the 𝗕𝘁liche 𝗹𝗶𝗴𝗵𝗁 is funding the build-up of a research infrastructure for the automated dismantling of traction batteries. And here you can see a very first concept. With this system, we will be able to disassemble complete traction batteries and develop the corresponding processes for automation. The goal is to dismantle complete battery systems fully automated from pack level to cell level. So even though the focus is disassembly, the production and assembly processes can also be taken into account here. This unit will be operational by June 2026. So there are many, many more processes and technologies that need to be developed in this area. So now is the best time to get in touch with us and be part of this circularity battery future. So feel free to contact us, ask for the slides, ask for a meeting online or on site, or visit us at our open house in September. Thank you.
Thank you very much. And yeah, perfectly on time. Maybe a quick question in the beginning. When you have a stack, a battery stack, how long does it take to disassemble it completely to the cell level?
We do not really take a cycle time into account right now. This station is for developing the processes to show that it is possible to automate or fully automated disassembly of the battery systems. Yeah. So cycle time will be a thing for the future, I say. Or
okay. Yeah. Do you have an estimate what is realistic?
So as it is a standalone unit and not a dismantling line, it will take quite some time, I think. I can't say any specific number right now.
All right. Thank you. Are there questions from the audience? Yes, I see one. Dimitri.
David, thank you very much for presentation. A quick question. Do you differentiate between the battery cell types, like cylindrical, pouch, prismatic, for your automated disassembly system?
So this system needs to be very flexible and adaptive for every kind of cell geometries, yes. And in the chat, there was a question for if we consider cell-to-pack designs. Yes, we do, but that's the part where the most development needs to be done right now in how to disassemble those systems.
Okay, I think we have time for one more question. If there's one, then please speak up. Otherwise, I am seeing a trend right now that a lot of producers are like the stacks are completely glued in, like the cells in the packs or in the modules are glued in. And now there's a new trend to do like cells to chassis, where they even integrate it directly in the chassis of a car. Maybe can you give some insights? Is that a trend which makes sense when looking at the recyclability?
Actually, no. So it's a very good thing to have the battery very centered within the car and not spread across the chassis or something else. So it will be more difficult, of course. Yeah.
Yeah, I think so too. I think these are two competing interests we see right now in the market, and yeah, let's see how that is developing. But if there are no further questions, I think we will move to the last speaker of today.
Yes, I think this is Andrew. He is, I think it's a very interesting presentation because it's about manganese in batteries, and he is very convinced that manganese is the safest bet in batteries. And therefore, handing over to you, and the floor is yours. And everybody who has this, please mute yourself, please.
Hello, everybody. I am going to speak about something completely different now. Not much about technology, but more on about the market and the money. So if you are somebody like Sandra Kreiner, who asked us a question at the beginning, how she could involved in battery business, having just graduated from the chemistry department. And she might be wondering, which batteries technology she should choose as her specialty. The same applies to any investor who may be wanting to put some money into the battery business. And he's wondering, which technology will eventually win this race into electric future. So let's talk about battery materials. As you can see on this slide, the battery mix has changed significantly over the last 9 years. If we look at 2019, for example, and compare it with 2023, which is the last year I have the full data for, you can see the battery mix, the battery chemistry mix is completely different. So if we are going to make an investment or make a career decision, which will affect the next 5 or 10 years, how is it going to pan out? What's going to be in 5, 10 years in terms of battery mix, and which technologies which are going to win, and so on. So let's have a look at the basic batteries which are going to play important part in the next 5 years. To start with, the pie will be much bigger. At the moment we are talking about 1 terawatt hour of batteries produced. In 10 years time it will be 6 times as much, possibly up to 9 times as much. So the pie will be bigger. And so each slice of the pie will also be bigger. I'm drawing your attention to 2 particular technologies here is circled in red, which is NMCA, which is a Tesla battery with manganese, and also LMFP. At 2% each at the moment, they just registered on the radar for the first time in 2023, but they are going to grow big. So if you look at other battery metals, they all face some difficulties. There may not be enough class 1 nickel, and the price is volatile and may go up to 100,000. There is a choice. You don't have to do nickel. You can go LFP or LMFP. If you want to invest in lithium, it's under threat from sodium ion, which is making big inroads into the battery business. And the price is extremely volatile, as you can see on this slide as well. You can go sodium ion if you don't like lithium. Cobalt is already in trouble because it's victim of its own success, and the reason it comes from the Congo, and the price is volatile and so on. So it's all under some kind of threat. If you look at the prices of the three main metals, cobalt, nickel, and manganese, put on the same scale in dollars per ton of metal contained in the sulfate, you see that the other metals are very volatile. Manganese hardly registers on this screen. And it's cheaper many more times than cobalt or manganese. It's the only battery metal which grew in price over the last 15 months compared to other metals. And it's also technically very viable. Almost every OEM, car maker, battery maker, chemical maker like BASF or Umicore, they have the huge portfolio of batteries, both in production and in design, containing manganese. So manganese is very much the metal of the day. The battery packs are going to go bigger, from about 50 to about 140 kilowatt hours. It's everybody's friend. It goes for solid state, goes for LMFPs, goes for NMCs, and so on. And I expect it to grow about 15 times over the next 10 years. And it's produced everywhere, but there is a fly in the ointment, as we say in English. Majority of it is processed in China. So mining everywhere, but processed in China. So we need more projects outside of China. And if you need more information about this niche product, but very important for the battery market, you're welcome to come and ask more questions. Thank you.
Okay, thank you very much. Any questions to Andrew? Here we go, Dimitri.
Andrew, thank you for presentation, but did I understand it right? You manufacture manganese material, right?
No, I am market analyst. I've been covering manganese in batteries for 6 years, being in contact with majority of the future producers outside of China and having a good insight inside China as well.
But you know the manufacturers outside China?
Yes.
Okay, thank you.
Any other questions? Ankit, you just have to unmute.
Yeah, thanks. Hi, Andrew. Thanks for the nice talk. I have a question that you say 92% of the refineries are in China. Why is so? What are the challenges with the processing of manganese salts?
It's a question of purity. You have a significant manganese industry in India, but it's mostly producing for the agricultural sector, because other applications for manganese sulfate is essentially a fertilizer or a cattle feed addition and so on. And it's quite difficult to go from the sort of production of fertilizer to pharmacy grade medicine, if you like. We are talking about 5 ppm of impurities, even down to 1 ppm. These are very strict battery requirements from battery makers. So that's the main reason. But there is no reason why India shouldn't join China and take a bit of a pie.
Thanks.
I'm sharing the link for Andrew. He's just in the chat. Please contact him or link to him directly, so to get in contact with him via LinkedIn. And let's go for the next question. Florian.
Yes, I wanted to ask you, let's say you would have to produce a battery container that should also be scalable, so you could as well use 10, 20, and 30 containers and contact them. Like, would you recommend a certain technology? Would you think it would be a big advantage if it wouldn't matter which kind of batteries could be connected inside the container, so that it would be easy to just take the batteries in and out, no matter what age they are, no matter what chemistry? Do you think that could be interesting for electricity container? Would you say that the Chinese batteries are so good and so cheap, it doesn't really matter? You put just one chemistry inside and it will run so good that it would not make a big difference.
Well, as far as I know, this is already happening. So we have battery packs made of mixed chemistries, So different modules of different chemistries in the same battery pack. And we also start seeing mixing at the cathode level, at the cell level, mixing chemistry. So you may have a cathode which is a mixture of the powder on the cathode is a mixture of different chemistries, which obviously makes predictions for me very difficult.
Yes, I just pushed my link in the chat. So if you want to connect to me, please feel free connecting to me. I'm generally not accepting them. Just put something, a word in their battery or something like that. So because otherwise I might miss your invitation. Okay, we have another question, Theodore.
Thank you, Andre, for your nice presentation. So I should about the mixing chemistry because, for example, we have cobalt and manganese aluminiums, which are not expensive, which are really expensive, especially cobalt. But in your picture and in your presentation, you show that we can reach good performance with that. So how about a sodium battery? Because sodium battery is the potential replacement of lithium batteries. Sodium is cheaper and it's safer than lithium, and also it can provide high energy density. So do you think that mixing all these cobalts, especially cobalts, manganese, and aluminiums, can be a potential solution for future EV or hybrid cars in the future? Because I'm investigating on sodium, I think sodium could outperform them in the near future. So what do you think about that?
As I'm not an engineer, I can't answer the question regarding whether it's possible to mix lithium-ion chemistry with sodium-ion chemistry and put them together in one cathode. Possibly you can do it in one battery pack and adjust by electronics. But whether they could be mixed together, I don't know. I haven't heard of anything like that happening. But what I did hear is that the sodium ions are apparently coming, and they are not just for these electric scooter, electric bikes. They are apparently coming for cars, entry-level cars as well. And some people say we'll have 500 and even 800 gigawatt hours by 2030 of sodium ion, eating into the market share of lithium ion.
Actually, the test shows that the sodium batteries can outperform. Of course, they are cheaper than lithium, but also in terms of safety and stability, it is safe and more stable than lithium, actually. But if you compare these sodium batteries with the mixing of chemistry, so included cobalt, manganese, and aluminiums in one cathode, right? So you can improve maybe the energy density and capacity storage of one cell only. But the good things about sodium is about it is abundance. It's an abundant material. And the good thing about lithium is the lightest metal in the earth. That's why we can outperform with this. Okay, thank you very much.
These are technical questions, but from my point of view, I love sodium ion because they use about 1 kilo of manganese per kilowatt hour of battery. So they are big consumers of manganese, which obviously I like very much.
Yeah, exactly. Thank you so much.
I think, Ciro, if you want to present something on sodium, just let us know. I will push the link if you guys want to present yourself here in this round. Just make sure you put you simply register up for this one. So in this way, we have your name, we contact you. And anyway, what we will see in the future, and that is the normal way, whatever metal will win in the end of the day, and even if the metal is not better than lithium today, we will see the development cycles. You will see that capacities go down, go up, prices go down, stuff like this. This is a normal development cycle. We have seen that with electric cars. We have seen this with computers. Nobody's believing it, but this is normal. Prices are going down, efficiencies goes up, and we know that the price are always reducing and the technology is increasing, which make it at one point in time one technology better than the other, even if it's behind. So thanks everybody for joining here. I think we are in the end, so we are slightly in overtime. So if you have any ideas what you want to have a discussion on, please let us know. Contact to me directly, contact to Maximilian Wagner, and we will pick it up, and we will see you again in May. And have a nice Easter break, and then see you in May. Bye.
Thank you very much.
Thank you very much, Holger.
Thank you very much. Bye.
Bye.
Thank you.
Thank
Bye.
you.
Thank you.
Thank you.
Bye
Well
bye.
done.
Thank you.
Excellent organization.
Thank you.
It's Germany, you know.
Thank you very much.
Thank you very much, everyone.